Okay, I'm sure you see my screen now. That's
Correct.
what WebEx tells me. Okay, so the structure for today is I will make a brief introduction about geometric documentation in general and say a few things about the methods that we use. And then Professor Pantazis is going to talk about network setup and structural health monitoring. And we'll focus more on the data collection because we have we have divided the presentation in data collection and data processing. So it's we will more or less follow that scheme. And then Mrs. Tapeinaki will discuss about data collection for the documentation of the Holy Edicule. Okay, all speakers, apart from me, will talk about the what we did as the documentation team in the Holy Edicule in Jerusalem. Okay, and then Mrs. Chliverou, she's a trained photographer and a very valuable member of our team. We'll discuss about the parameters for correct photography. We are here. And some notions of computational photography. You see it's only about a quarter of an hour or 20 minutes. And then Professor Pantazis will say a few things about monitoring of the deformations and the results that we got. And Mrs. Tapeinaki will continue her presentation on data processing and the results. And if there is some time, we will have some question and answers, Q&A session at the end. So this is how we programmed the this afternoon, the 3 hours this afternoon. So would you like to say a few things? Or
I just want to say to all the participants that you are heading the survey and rural engineering team of that for the rehabilitation of the whole Edicule, and that the whole team is actually going to present all the results today.
Yeah.
And you are more than welcome to explain us all the details of this elaborate work that you did, and now we ended up having a fine three-dimensional model, actually more than one models, if I remember well.
Yes, you
in the sense that from various stages of the works.
You remember very well. It's not the whole team. It's some of the members of the team, the ones I mentioned. Of course, we were also supported by Professor Ioannidis and Ms. Soile and a lot of fine younger students or PhD students that helped us along, and also Dr. now Chilimandu. She did a very specialized action which we could not include in those 3 hours, unfortunately.
Yeah. Okay. I would like just to ask all the participants to mute their microphone, just to avoid having some background noise to help the speakers. And if they don't want it, they can even switch off the video until they want to make a question and they want. Okay, the floor is yours, Professor.
Thank you very much. Thank you. Okay, apart from giving courses and teaching here at the laboratory, I'm also an ICOMOS board member, the International ICOMOS board member, and also I'm the vice president of SIPA Heritage Documentation. It's an international scientific committee of ICOMOS specialized in heritage documentation. So some introduction about myself. Now, we all know that cultural heritage is in danger, and it's in danger because of many reasons. As you can see, there are a lot of reasons that endanger cultural heritage, like natural hazards or violent actions or looting or globalization or urban growth or whatever. And I have here some examples of this destruction. This is an iconostasis of a remote Byzantine church up in the mountains of northern Greece, and you can see that there are some icons looted. Some icons are missing from very valuable and very old icons. So this is a case of looting. This is another an archaeological site very close to Athens, which is in a place where it gets flooded every 5 or 10 years or something like that. This is one case about 7, 8 years ago. So this is a phenomenon, a natural phenomenon that causes damage. Earthquakes, this is the city of Bam in Iran. You can see how it was before and lower, in the lower picture after devastating earthquake. So this is to make sure that this is the result of another destructive earthquake that happened in Kathmandu. This is before on the left and after on the right. And of course, we know of violent actions in the Middle East. And recently we had the fire in Notre Dame in Paris. So this gives you an idea of the danger or the dangers that cultural heritage is exposed to, and what we need to protect it. We need documentation, and this is what we are going to talk about. We need accurate measurements for restoration, reconstructions, structural studies, or whatever. We need monitoring, and this is also something that you will get informed how we implemented it in the Holy Edicula in Jerusalem, and of course proper management, which is missing in most of the cultural heritage sites, proper heritage management, and of course preservation, and most important, I think, is the public outreach. We have to raise the awareness of the public to protect and take care of cultural heritage that is present in the area where they live. Now, for the protection of cultural heritage, which is an obligation of all generations in order to preserve historic memory and, let's say, give the cultural heritage in a better state to the next generations, there are some international organizations. Foremost is UNESCO, of course, and UNESCO has formed ICOMOS, the International Council of Monuments and Sites. And one of the scientific committees of ICOMOS is SIPA. So you see the whole context that I just mentioned, those organizations before, and how they relate to each other. So ICOMOS is the official technical advisor of UNESCO concerning the cultural heritage, and it has about 10,000 members all over the world. And of course, it has ICOMOS chapters, as they are called. They are called national committees in almost all countries. So I will focus more on the documentation, and the necessity of the geometric documentation was firstly written down and signed in the Venice Charter about 50 years ago. And in Article 16, in many, let's say, spots in the Charter, but in Article 16, it clearly says that before any intervention, before any study, the documentation of the monument should be performed. And we see the geometric documentation as a subset of the integrated documentation. Nowadays, we have the ability of documenting in many different ways: bibliographic, historic, archaeological, architectural, cartographic, legal, whatever documentation you think of is part of the integrated documentation of a monument. So one little part is also the geometric documentation of the monument. And this documentation in general calls for interdisciplinarity. We have to keep that in mind. We cannot do the things alone. One discipline cannot cover every need of cultural heritage. So we need archaeologists, we need architects, we need ICT specialists, we need restorers, we need civil engineers, we need chemical engineers, art historians. Every specialty has something to offer, and we have to work in an interdisciplinary way. And the rehabilitation of the Holy Edicule that we performed in Jerusalem is a fine example of many different experts from different, let's say, origins, scientific origins. We have worked together for the final outcome. So how do we define the geometric documentation of a monument? After so many years that we are involved, we have proposed this let's say, definition, that is the procedure of acquiring, processing, presenting, archiving, and storing of the data which are adequate to determine the position of the monument in 3D space, the true form, shape, and the size of the monument in 3D space at a given moment in time. What does that mean? It means that monuments, like all constructions, are changing over time. So when we decide to do a geometric documentation, it's valid for that moment in time. That moment could be a month, or could be, let's say, 3 months, or could be a day. But it is a moment in the lifespan of a monument. If that monument changes, we have to redo the documentation, or we have to monitor the changes, these changes, so that we can document the deformations and how the monument is changing. Now, if we look more closely, the geometric documentation is the orthogonal projection of a carefully selected set of points. So we select some points, or a lot of points, from the surface of the monument, and we orthogonally project those points on horizontal or vertical planes. These are the drawings, okay? And I mean the 2D drawings that we know so far that constitute the geometric documentation of a monument. And the scope of that is to record all geometric properties of the monument in the best possible way. So we want to relate to the expert that is going to use our products how the monument is shaping in 3D space, what its size is, where it is positioned, etc., etc. Okay. And the methods that I will very fast, very quickly go through have the benefit that they all are able to refer all these points in a common reference system. So, for example, in a church, the point on the cross or the bell tower is related exactly to a point in the basement of the church. So this is to visualize what I said before. So you see those vertical and horizontal planes, and this is a monument, and we have to stress a few essential principles like scale and accuracy. And this is very determinant for us, documenters, or let's say geomatic experts, that the scale and the accuracy, and of course the resolution of the final drawing or of the final product is crucial for the methods that we're going to use, okay? And so we have in our hands a lot of tools to acquire data, like hand measurements, which is very simple. Everybody can understand that. We have a topographic methodology that we can use, or photogrammetric methods, or laser scanning. Lately, that do I see a hand raised by Aliza van Sweden? Have you raised your hand? No. Okay, lower your hand, please. You can do it. Thanks. Now, in this diagram, I have put all the methods that we have available in a system that on the x-axis is the object size. So the further to the right we go, the further, the bigger the object is. Like at the end is perhaps the Earth, okay, or a planet. And on the y-axis, we have the complexity of the object and the necessity of the points, how many points are necessary to describe the surface. Don't forget that I told you before that we select some points and we project those points. So the further up we go, the more complex the object is. And you see all these methods that the tactile methods, the hand measurements, the topometric methods, tachyometry, GNSS, which is another expression of GPS, is a more general one. And we have on top close-range photogrammetry and 3D laser scanning. We have the drones or aerial photogrammetry and LiDAR, that is laser scanning from aeroplanes. And we also have satellite remote sensing. You see a difference in color. The methods on the bottom are yellow and the methods on top are blue. Their difference is that the blue methods, they use images, while the yellow methods do not use images. Okay, so this is the only difference. And you see that there are some overlaps between the areas where each method is more suitable to be applied. So I will, or we will focus more on the light-based 3D measurement techniques. That is, that we use light. So we have passive and active methods. Passive in the sense that some other source of illumination sends light and we record the reflection. And active sensors are the ones, or active methods are the ones that we send some radiation and we record what is reflected. So laser scanners fall under this category because we send some laser beam and we record its return. While photogrammetry, that we take some pictures, or topography, that we just measure the image of a point through a telescope, we need some source to illuminate the object. So these are the two the difference between passive and active methods. Now, what is photogrammetry? I'm not going to present many words here. I will just show you a picture. You see, this is the sketch of a camera. And in the middle, you see at the focal plane, you see a guy who is an artist. So it means that we have to take proper images, and he's imaging what he can see through the lens, but he's also measuring. You see that he's measuring. So we measure suitably collected images. Okay, so this tells almost everything about what photogrammetry is. And if you want to go to a more detail, how does it work? It simulates human vision. So let's say that we have a human here, and you see the two cameras that the human has. And by using those two cameras, we humans understand depth. And what we do is we deceive our brain, and we bring two images in front of our eyes. So we don't see the real object, but we see two images of the object, and we think, or we fuse, our brain fuses those images and sees depth. So we exploit that, photogrammetry exploits that action and is able through either manual or automatic procedures to determine depth and ultimately determine the position of all the points that we need, A, B, C, etc., etc. So it's actually a mathematic or geometric description of a natural phenomenon. Now let's see how terrestrial laser scanners work. I'm sure you don't listen to the music because I didn't share the video. But what you see is how the laser scanner sends a beam and records the return. And each scanner does that several 100,000 times per second. Actually, we are now up to 1 million or 2 million points per second with the latest models. And what the result is point clouds. Point clouds, that is millions of points of the surface of the object. So I will go fast because I started late and I don't want to delay you very much or steal your break. And actually, most terrestrial laser scanners have the ability to scan 360 degrees around a vertical axis and 270 or 300, depending on the model, around a horizontal axis. So they practically scan everything. They send laser beams and record its return. And of course, they determine the position of the points in relation to the center of the instrument, the center of the laser beam. Now, going back to the data acquisition methods, all these nice methods that we are using and we used in Jerusalem are based on direct measurements of lengths and angles in the object space or on images, and indirectly we determine the coordinates of the points. Okay, so the actual measurement is either the length and the angle or the direction of the rays. They ensure high, common, and predetermined accuracy, and this is very important for large-scale documentations like the one we implemented in the Holy Edicula. And they can be adapted, they are flexible, they are quick, and they are efficient. And they are the most cost-effective, not cheap, cost-effective in the sense that they are the only methods to respond to any kind of specifications with the less possible cost and the maximum benefit. So they are methods developed exactly for these applications. So the drawings that we usually produce are a general plan or horizontal sections, as I said before, or facades, that is the outer facades, the outer surfaces of a monument, or vertical sections through key positions. And also sometimes we need to have developments, that is round or cylindrical or spherical or other non-planar objects that should be developed for the sake of the further studies that are going to be performed. We also have the ability since, let's say, 10, 15 years to produce three-dimensional models, that is drawings in 3 dimensions, and this is very, very important, and photorealistic models, and all that can be either in analog form or in digital files. Now, how a 3D model can be in analog form? When it is 3D printed. Okay, so there are answers to these questions. And of course, we have vector products, that is lines on paper, or in a CAD environment, or we have imagery products, that is images that are in orthogonal projection, and this is also a very important product. Now, the sources of metric information, as I said before, is either topographic measurements or photogrammetric measurements or point clouds from terrestrial laser scanners. And you see what we can get with each of these methods, and they have a common denominator. And the common denominator is that we can measure in 3D. And this is very, very important because, as I said before, the points are all referenced to the same reference system, and they can be related to each other. Just an example of a combination of raster and vector images. This is an older application that we did in a Byzantine church, UNESCO World Heritage Monument here, very close to Athens. You see a sequence of raster product and then a vector product, and then a combination of raster and vector. It was a section, and then we came back to the eastern facade of the church. And I will finish with this slide. It's not very easy to do these kind of documentations in large scales, as it was the case in Holy Edicula in Jerusalem, because the objects are quite complex and they require understanding of the structure of the monument, and this is very, very important. And this is where interdisciplinarity comes in. We have to be very close to the object to take images, and this makes the anaglyph of the object very big compared to the shooting distance, and this adds to the difficulty of the processing. The accuracy requirements are usually very, very high. Sometimes we have different reference systems because we want to project something in a different system, and we have to be very agile with changing reference systems. People are now aware of the possibilities, and they demand alternative products. Unfortunately, there is an international lack of widely accepted specifications. There are no specifications widely accepted to document monuments like that. And I would like to finish with this statement that passion for cultural heritage is absolutely necessary. I also say that to the students: if you are allergic to cultural heritage and to archaeological sites or to museums, etc., you are in the wrong course. So I thank you very much. I'm sorry I've taken a few minutes more, but the introduction, I did my 20 minutes, I think, but we started a little bit later because of me. So thank you for your attention. If you have any questions, please save them for the end so that we can have a discussion just before 6 o'clock. Thank you. I should unshare now, and I have to find how to do that. Stop sharing, share, content, stop sharing, and find. Okay. I think now that it's the time where Professor Pantazis is going to present his talk on network setup and structural health monitoring. Professor Pantazis, are you there?
Of course.
Okay.
I'm there. And,
perfect.
So share my presentations. It's okay.
Yes.
Presentation is
Perfect.
okay.
Perfect.
Okay. Good afternoon for me. My name is Georgopoulos. I am a professor at School of Rural and Surveying Engineering and Geoinformatics, of course, National Technical University of Athens. And as a member of research group for the monument protection, I'm going to present some things about network setup, monitoring of structures, and data collection. 2 decades previous, in the years 1993-1999, the laboratories of general geodesy and photogrammetry of National Technical University of Athens undertook and executed the complete geometric documentation of the Church of the Holy Sepulchre for the Greek Orthodox Patriarch. In this slide, we can see a result of this documentation by using geodetic and photogrammetric methods. This the new work in the Jerusalem church is about of the Holy Edicula. For the documentation of the Holy Edicula, different geodetic and the photogrammetric methods was used. First of all, the works of the data acquisition took place after the closure of the church because it is difficult to do measurements with people. The methodology implemented for the production of the above described products applied the most contemporary geomatic techniques and of course specialized instrumentation. These data were georeferenced to an already existing local plane projection reference system from previous work of the previous works 1993-1999. For this purpose, a local 3D network was established at the site around of the Holy Edicula. This geodetic network is appropriate for the reference of the three-dimensional model in the common reference system and the determination of eventual deformations and micro movement of the Holy Edicula. In this slide, we can see the network, the geodetic network was this network was connected and related to the geodetic network established during the period 1993-1999. The coordinates X and Y refer to a plane projection in a local Cartesian reference system, as Mr. Georgopoulos told previous, while the elevation H is the orthometric and refers to the mean sea level. The connection between the two systems, previous system and now system, is appears in this figure with the numbers 10013 and 10012. The connection, the network is composed from of 8 points. This is the 8 points S1, S2, S9, which were established in order to avoid any perceptible intervention at the site, ensure the permanence of their position not only during the measurements, but also for the future needs of the work, and be feasible the measurement of all the necessary points for the three model and the deformation and displacement determination of the Holy Edicula as well as its dome. The network points are 5 points which were established all around the Holy Edicule by using special marker. This is the photograph of the network points outside of the Holy Edicule. 2 points which were established at the internal space of the Holy Edicule by using appropriate marker, and 1 point which were established on the roof of the Holy Edicule in order to support mainly the dam's measurements. Measurements, the data collection of the measurements, measurements of horizontal distance and vertical angles and distances were carried out between all the points of the 3D network by using the total station like a TCRM, which ensures nominal accuracy of angles measurement about 1 arcsecond, 1 millimeter for the distance measurement on a reflector, and 2 millimeters for the distance measurement in reflectorless mode. For the geodetic measurements, just a minute to avoid this. Okay, for the geodetic measurements, apart from the total station, the following equipment were used: tripods, triplets, reflectors, support bases, reflectorless. This is a photograph about the position of the total station out of the Holy Edicule. In the Holy Edicule, accurate geodetic measurements was carried out in order to determine eventual deviation and deformation of the Holy Edicule. 4 horizontal sections of the dome of the Holy Edicule at the elevation of 6, 8, 8, 18, and 12 from the interior floor. Measurements along the metal supporting beams which are outside of the Holy Edicule. Determination of the declination of the 5 basic columns at the north facade and the counterpart columns at the south facade, in order to comparison with their corresponding position in the British Register in 1947. This is some results of these measurements. This is the position of different 4 horizontal sections of the dome at the height, at the different height. 3 circles were produced, 3 or 4 circles, because this circle is very small. These 3 circles were produced whose centers differ less than 7 millimeters in position. From this figure can be deduced that the dome of the Holy Edicule is vertical. It does not deviate from the vertical plane. For the determination of the declination of the basic columns at the north and south facade, geodetic measurements by using total station in reflectorless mode was carried out. In the next slides, we can see some differences between different time periods. 1947 January this is the first geodetic measurements. In this diagram, we can see the differences between 1974 and August, when the position of these columns changed by using mechanical methods, and finally this is red color shows the final position of the column at the north and south facade. Especially for the geometric documentation of systems and underground tunnels, precise geodetic measurements was carried out. It is very important for the team for the group of the monuments protection to study the position of these systems all around of the Holy Edicule, and for this reason it is appropriate to documentate of these systems. For the geometric documentation of an underground tunnel, which is situated at the northern side of the Holy Edicule, special geodetic methods have been applied using, of course, total station without reflector. This tunnel reaches the Holy Edicule at its north side under one of the iron columns. This is the ground plan of the tunnel, and this is the photograph about during the measurements of this underground tunnel without, of course, light. And of course, the condition is very difficult, not only for the instrumentation and for the people, of course, but it is very important to geometric documentation of this tunnel in order to find the relation, the position, of course, and the relation, the position of this tunnel and the Holy Edicule. This is the ground plan after the geodetic methods, and this is the vertical section by using geodetic measurements. This documentation, of course, was referred to the 3D geodetic network projection, so that to be the correlation of the tunnel's horizontal and vertical position with the Holy Edicule. And same geodetic and photogrammetric methods was applied in order to documentation of Corbus excavation, which is situated south of the Edicula in the Rutuda. Figures ground. This is the ground plan. This is the Corbus excavation near the Holy Edicule. About the distance of this excavation is about 1060 meter. The depth of the floor of the excavation varies from 1 meter to 0.65 meter. And the roof of the excavation is located about 30 centimeter under the actual floor. This is some of the geodetic methods was carried out in Holy Edicula in order to documentate the real situation of Holy Edicula by using, of course, instrumentation and appropriate geodetic methods. Thank you very much for your attention in this part of my presentation. And if there are any questions, I think that will be at the end of this session. Thank you.
Thank you very much, Professor Pantazis. Now, according to the schedule, we can have a 5-minute break, if you agree, so that the next speaker, Mrs. Tapeinaki, prepares herself. Okay, unless, Kyriako, is that okay if we...
I think it's best for everybody because to have a 3 hours course, it would be rather tiresome.
We will start at 4 o'clock sharp.
Okay? Everybody's connected, and we will see when somebody talks.
Athens time, so it will be 3 o'clock for our Italian colleagues.
Okay, thank you very much.
Okay. Σέβη, αν θες, μπορείς να μοιραστείς την οθόνη και να ξεκινήσουμε στις 4. Τέλεια, μια χαρά είναι.
Η κυρία δεν κατάλαβε ότι πρέπει να κατεβάσει το χεράκι.
Δεν πειράζει.
Αυτό το χεράκι λέτε που βλέπω, το είδα και εγώ νομίζω ότι είναι mouse αυτό. Τώρα κατάλαβα.
Εντάξει. Ναι, όχι, έχει το...
Εντάξει, κατάλαβα.
Εντάξει, Σέβη, 4 η ώρα ξεκινάει.
Okay.
Hello again. I think we can start. It's already 4 o'clock. So, dear Sevi, you can start. The floor is yours.
Okay, good afternoon from me too. I hope you see my presentation. Okay, I start.
Yes, perfect, perfect.
Okay, thank you. I am going to present you the data acquisition for the dynamic integrated geometric documentation of the whole Edicula during the rehabilitation project. Okay, it worked. Sorry. The rehabilitation project of the whole Edicula was carried out by the interdisciplinary research group for the protection of monuments of National Technical University of Athens. The Holy Edicula of the Holy Sepulchre is in the Church of the Resurrection in the old city of Jerusalem. It is a very complex construction with very rich exterior and interior decoration. Its dimensions are 13 meters length, 6 meters width, and 12.5 meters height. It consists of the Holy Tomb Chamber, the Chapel of the Angel, and the Onion Tomb on top. And it covers, completes, and protects the Holy Rock. During the rehabilitation project, the Holy Sepulchre was open to the public during the day, and for this reason, the exterior area was properly designed so that the pilgrims could had access to the entrance, and at the same time, works were allowed to the exterior. So we had all day access on all sides of the exterior and on the top. Now, geometric documentation was done after 7 important phases of the project, including the initial and the final state. And just to mention here that during removal of the metal frame, a photographic documentation of the procedure took place. Each time, we worked in different areas of the Holy Edicula according to the needs of its phase. And due to the volume and diversity of data, careful data management, storage, preservation, and maintenance was mandatory. You can see here that we had to, we acquired data to 7 times. On February 2017, photographic documentation took place. I mentioned that before. And at the end, we had more than 10,000 images to process, and a lot of millions, billions, I can say, of points to process, to edit. Data acquisition was done according to the specifications and the methods we would apply each time. While all methods and procedures of acquisition had to be adapted to certain restrictions imposed by the complexity of the building, the attendance of pilgrims that I just mentioned before, and the continuous interventions. Therefore, data acquisition had to be done correctly and carefully, but quickly, to catch up the interventions. In some days, we had to work 20 hours continuously. Data acquisition procedures included precise geodetic measurements that Mr. Georgopoulos just analyzed in the previous presentation. Image capturing with two DSLR and one action cameras, various lenses, and for the interior, we used Studio Flash. Finally, laser scanning took place with 5mm scan density and more than 70% overlap between scanners, between two scans. We can see here some examples from imagery of the exterior. You can see there were a lot of obstacles like the scaffolding. We had to take very close images like this one to have the details of the object that we had to document. Here is an example of a scanned point cloud. This is the point cloud from the initial state on January 2016. You can see here that a lot of people were also scanned, and a lot of work was needed to clean this point cloud. Here we can see the scanner positions for the exterior of the whole edicule. And here is a top view with the scans of the exterior. You can see that we placed the scanner on the rotunda that gave us the possibility to be on top for the high points of the edicule. And these are the scans for the interior. Here is a view of the point cloud that we acquired during on October 2016 for the 14 panels. You can see that the scanner positions are 50, and if you noticed previously, the scanner positions that we needed for the whole initial state was 58, and here we had here it's not working correctly, but you can see that I will show you. The scanner was placed very close to the object, and we had to take all this to place the scanner to all these positions to have all the data that we needed. Unfortunately, the slide didn't work. Never mind. This is another view of the same scanner point cloud, scan point cloud. And this is a view of the final state on March 2017. More clean, because the scaffolding and all obstacles were not there anymore, but still we had obstacles on top of the edicule. Now, during data acquisition, we had to overcome some problems, like when scanning the interior of the Onion Dome. A special construction was made to place the scanner in the center of the dome, and you can see the complexity of the interior of the dome. So we needed another scan, and we had to fix the scanner on the top of the dome for an upside-down scan. This point cloud was used later for the 3D reconstruction of the internal wooden structure of the dome. The scanning of the interior domes were also impossible because of the presence of these candles, as you can see in the images. And the solution was given through the holes on the top again with an upside-down scan. And here the stability of the scanner was ensured by the patience of these three colleagues, Andreas, George, and Panos, that they had to put the scanner and hold it steadily. Another place with no access on March 2017 was the south part of the exterior dome. We needed a scan from high. So using this unstable lifting machine, we tried to raise the scanner together with a volunteer. And maybe he seems very happy here, but it was very dangerous and unfortunately with no success because, as I mentioned, the lifting machine was not stable. And finally, narrow spaces made it very difficult for us, like the internal stairs, where here Andreas was starting the scan and then quickly had to disappear from the side of the scanner. And I think it was I finished later, earlier than I had the presentation. Here it's where I end the data acquisition. I could start to present the data processing, or we could go further with the presentations, because data processing is more, I have more to say about data processing and results.
I suggest we go on according to the schedule, and we listen to Mrs. Chliverou now, Regina, and then we can have the break maybe earlier, and then we will continue normally. It's better to follow the way we had agreed on the sequence of the presentations.
Okay.
Okay, thank you very much, Sevi. If you would like to stop sharing.
I'm trying, I found it.
It's an orange button, yeah.
Yes, I found it. Thank you very much.
And I would like to ask Regina, Mrs. Chliverou, to share her screen. Perfect. Okay, we can see your presentation, Regina. You can, yes, excellent.
Okay, thank you.
You can have some more minutes if you like.
No, okay. Good evening. I'm Regina Chliverou, and as Professor Georgopoulos said, I am the photographer of the team of the Photogrammetric Laboratory at the NTUA, and I will present you the way we worked so as to shoot the photos that we used to create all the 3D models of the Holy Edicule before and after the rehabilitation. Sorry, but it's not going to the next slide. Okay, this way. I will start my presentation by showing you the photographic equipment that we chose to use against all odds we had to face inside and outside of this monument in order to achieve the best possible results. First of all, I'd like to refer the cameras. We used two calibrated SLRs full-frame cameras with CMOS sensors. The one has 21 megapixel resolution and 6.4 microns as pixel size, and the other one has 20 megapixel resolution and 6.6 microns as pixel size. I didn't mention the company of the camera on purpose. It makes no difference. Then I'd like to refer the lenses. We used different lenses with varying focal lengths, but always fixed lenses. Never zoom, as it is widely known that fixed lenses deliver better quality in both sharpness and geometry. The truth is that the majority of the images were taken with a 24mm lens, and that's because the interior of the Holy Edicule is very narrow, as you can understand. Last but not least, about the photographic equipment, I'd like to refer the type of lighting we used to shoot these pictures. The decision of what kind of lighting should we choose was taken after visiting the monument at the very beginning of the project, where we noticed that, especially inside of the Holy Edicule, was, and it still is, completely dark, and the only source of light is a few candles. So immediately and in full agreement, we decided to use a studio flash system. And that's because this is the ultimate source of light in matters of intensity and accuracy at color temperature. Regarding the intensity, it was our first concern because we wanted to achieve absolute clarity while shooting the pictures. So, by using this kind of high luminance source light, we secured the use of the smaller aperture value for every lens we had at our disposal in order to achieve the largest depth of field. To be clear, when I'm saying smaller aperture value, I mean the smaller opening of the aperture. For example, values like 11, 16, 22, etc. And all this always, of course, in combination with the option of the one of the lowest sensitivities ISO, and to be more specific, at 100, targeting to noise reduction. Additionally, using the synchronization speed of the flash, we ensured that we could shoot the photos handheld without a tripod, which was a big relief for us due to the narrowness of the place. Easily someone can imagine how difficult it is to move around in a narrow place with a tripod and trying to shoot photos as quickly as possible, because it was a fact the limited time we had to work. Here, it's very important to be mentioned that the Holy Edicule during the rehabilitation didn't stop receiving the pilgrims or to carry out all the religious services. So we had to move really fast and synchronized. We started working, as you can see in the picture in this slide, with the best intentions by using tripods. And we ended to handheld both the camera and the studio flash, as you can see in the picture in this slide. At this point, I'd like also to mention that approximately 11,000 photos were taken so as to create all the required 3D models. The second reason we chose a studio flash system was the color temperature. We had, with absolute accuracy, white light, and precisely at 5,500 Kelvin degrees at every single shot, because a flash has an extreme accurate performance in each burst, and also especially a studio flash with its big intensity overrides any other lighting of different color temperature. Furthermore, inside of the Holy Edicule, you have to deal with so different materials, and each of them reacts differently to light that falls on it. And if the light does not have a clear and stable performance, there is a risk of chromatic aberration, and as a result to be lost the balancing between the color channels. So, by using a studio flash system, we didn't have any color deviation, and we managed not to need radiometric corrections, the technical process that fixes color issues and makes the image to look like the original subject. This is very important in photography, as it is known that even the slightest correction in a digital imaging program reduces the clarity of the image, which is something that needs so much effort in many ways to be achieved. As a third advantage of the Studio Flash system that we chose to use was the ability to attach to our flash light modifiers, as they called. Light modifiers in studio photography are devices we attach to or hold in front of our flashes in order to control the light pattern that the flash emits in normal conditions. These would be considered any photographic umbrellas or soft boxes or reflectors. In our case, we had soft boxes. Soft boxes are diffusers that soften the light by scattering it over an area larger than the source light. As a result, we had the same quantity and quality of lighting throughout the frame each time. We used a medium size of soft boxes, and particularly 45 to 45 centimeters. The reason we picked this medium size was, as I mentioned before, the narrow place we had to work, and also because we had to be flexible in movements so as to shoot many pictures at so little time. Additionally, this size of softbox allowed us to shoot at the same time small areas as well as wider areas without changing equipment and spending time. Another thing that is worth mentioning is that we wanted an independent flash from the camera in order to be able to direct the lighting according to the requirements of the subject at every single shot. This, of course, created the precondition for the employment of two people for the shooting. One to do the photogrammetric shots with the camera, and the other to handle the lighting. In summary, so far I have talked about lighting problems, space problems, and lack of time problems. Now I would like to share with you these images that present perhaps the greatest difficulty we faced during the project of the rehabilitation of the Holy Edicule, referring always to photographic issues. And it was back in 2016, in the first phase of the project, during in which the monument was both externally and internally surrounded with many kinds of scaffolding. It was a real challenge to capture in photogrammetric way all the surfaces that were behind the supporting barriers. Now, I would like to continue with another topic in which a completely different photographic approach was given. Here I have to say that the main contribution of the photographic laboratory to the rehabilitation of the Holy Edicule was to shoot photogrammetric images for the creation of 3D models. But as an additional contribution, we covered and some other issues and needs of the project. One of the most important was the removal of an existing, at that time, iron frame, which was installed around the structure in 1947 by British engineers in order to help avoiding a collapse. So, when the rehabilitation project members announced that it is safe to remove the iron frame, the photographic laboratory traveled back to Israel one more time to record that historic time. After a discussion with the field crew, they informed us that they will start working from the south side of the Holy Edicula, and it will definitely be a process that will not end overnight. At this point, let me inform you that most of the field work, not to mention all of it, was done at nights when the holy place was closed. So, under these conditions, and when I'm saying these conditions, I mean that we had to record a process which would probably be in progress for 2 to 3 nights. We had to visualize this process at a final product of 1 to 2 minutes the most, presenting the work of ours and communicating to the public. Our decision was one way. We chose the technique of the computational photography, the time-lapse. Time-lapse photography is a technique in which a large number of images are shot at regular intervals, and then they are composed in order to form a video and create the impression that the time lapse. And as a result, the viewer watches a process of a time long in a few seconds or minutes. Now, to refer a little bit to the technical settings, as you can imagine, the camera was mounted on a tripod so as to be stabilized. The second very important thing to do was to set the camera in manual focus so as the focusing point of all the images to be maintained at the Holy Edicula and not to every person that stepped by in front of the camera. Then we adjust the camera in manual mode so as to have the absolute control of the exposure and set the aperture and time value as convenient as possible, first to achieve large depth of field by using small aperture value, but also to keep aperture value completely stable in order to be stable also the depth of field at all the images. Then we used the lowest sensitivity ISO targeting to noise reduction. We set the interval time to 15 seconds. That means the camera was taking a shot every 15 seconds. About 6,000 photos were taken, which means we had a lot of editing. Then the camera was plugged in all the time, so we didn't have to worry about the battery. Finally, a medium time value was chosen in order to freeze as much as possible the movement of people passing in front of the camera. And when I'm using these expressions, like freezing the people, I cannot help but remember the joke about the photographers, that they are violent people because first they frame you, then they shoot you, and finally hang you on the wall. Thank you for listening me, and I'd like to ask Mr. Georgopoulos if I may show you the time-lapse video now.
Of course, of course. And when you share the video, when you share your screen again, I
Yes.
think there is a button saying that share also the audio. So unshare and then reshare and
okay.
find this button and just check it so that we can listen to the audio, because I know that it's real sound.
Yes, let me choose this. Okay, I think I find it. Let me inform you to adjust, please adjust the volume on your computer so as not to be very loud, because the video is embedded with real sounds from inside of the holy place during the work for the removal of the metal frame. So you will hear the sound of various tools, and it's maybe be a little bit annoying, so adjust the volume of your PCs. I hope that through the video you will be traveled back in time in the holy Edicula.
If I may add, Regina, that
Yes.
the metal frame was cut with a special tool that cuts iron with air under pressure, so that the wall was not damaged by fire or other means or saws, etc., etc. So it's a special. It's called, I think, plasma tool, and Kyriakos will correct me if I'm wrong.
It is plasma tool, and that's why the viewers will see a lot of wooden plates protecting the edicule between the frame and the surface of the edicule, just to protect for any damage that may have occurred with debris or with the flame.
And it was developed by our School of Mechanical Engineering, correct?
Yes, indeed.
Regina.
Okay, I'm starting the video. Adjust the volume, not to be loud. Andrea, do I have share my the video?
Not yet, not yet. We can't see it.
Do you see it?
Not yet.
It did work earlier when we tried that, Regina.
Andrea, do you see the video?
No.
No. Okay. Let me try again.
Take your time, take your time.
Okay.
Actually, it's a time lapse, so take your time lapse.
Take your time lapse.
Just a moment.
Something is changing.
It's coming, it's coming. Thank you very much, Regina. It was really impressive. I hope you all agree to that.
May I add to those that are not familiar with the whole process that if they kept seeing a Clark into the video, the Clark was used to lift the plasma flame at elevated heights. That's why it was in most of the video, the Clark, the lifting machine. They were actually putting the plasma flame on the elevated machine to reach higher locations. That's all.
Okay. Thank you very much, Regina. Now we are a bit early. We're running a bit early, and that's a record. So I suggest we take a break now for a quarter of an hour as foreseen, and we start at 10 to 5. Okay?
Okay. Does any of the participants have any questions before we come back, or do you want to leave the questions for the very end?
Since I said we leave them at the end, but
okay.
if we have some time, you're right, Kyriakos.
If somebody else, I mean,
if somebody has a question or a comment, please feel free to unmute yourself and express yourself. This is your chance to become famous.
Well, I would like to become famous. I have a question, Professor Georgopoulos. What was the main difference between the Geometrical Documentation Survey from 1999, 2003, and 2016? I mean, what was much different from 16 years ago? Because if I remember well, both you and Professor Pantazis participated in the original group, if I remember correctly.
True.
Just for the viewers to understand what is important now.
And I think for a couple of years also Regina was present then.
Okay, sorry.
Yes, the difference is the 20 years that divide the two documentations have seen or have brought to us a lot of new equipment. So I think that the documentation we did back in the 90s was one of the last documentation that was done without digital images or laser scanners. We didn't have a digital camera and we didn't have a laser scanner. So this made us turn our, let's say, efforts to use more traditional or the best, to our knowledge, traditional methods that we had available and instrumentation. And I must say that the group was included a very competent architect who was very agile with 3D AutoCAD. At the time, it was, I don't remember which version of AutoCAD it was, and he was exploiting to the full our 3D points and produced those results that you saw from Professor Pantazis. One slide was included one of the drawings, and the results that we produced were vector drawings. So having no digital cameras, and the technology was very poor to scan the analog images and produce orthophotos, because also the instrumentation and the software available then was not that competent as we have now to produce orthophotos. We were, let's say, deprived of producing nice results like the ones that you're going to see now in the second part of our presentation. However, I think that another difference, or a real difference, was that then in the 90s we did the documentation of the whole church, actually of the whole complex. and we didn't confine ourselves to the Edicule. In fact, we didn't touch the Edicule at all then, because very recently, I think it was in the early 90s, 91 or 92, just before we were commissioned to do this documentation, that the British, again, did a very detailed documentation of the Holy Edicule. And we had discussed it. It was a professor from City University in London that I personally knew, and we discussed, and we had the promise that we were going to be given this documentation, but unfortunately, in the end, there were some mix-ups. You understand that when people are going to give data or results, they are very much afraid. And so we never got these results to embed them in our documentation. So actually, the documentation was referring to the whole church, but the Edicule then.
Yeah, but the plans are still very impressive and are very useful even nowadays, I think.
Oh, yes, yes. I personally, and I think also Georgopoulos and Regina are, we are really proud of these results for the conditions, considering the conditions that we worked and the instrumentation that we had. Okay. If you like to add something on that, because I think it's valuable to hear your opinion.
Yes, another difference, Andreas, was the evolution of computers and the software about they analyze all these measurements. This period, there is a possibility to choose different computers, different softwares, and to produce not only horizontal and vertical diagrams, but 3D model of any subject.
But I think it may sound like your job is easier nowadays, but I think it's the opposite. From listening to Regina and Xrva about the thousands of images you have collected and the thousands of points you have collected, probably it becomes more difficult, and you need to be a real engineer to understand the structure first before you actually compose a 3D model of the structure, because otherwise you may make errors. I don't think it sounds like our job is getting easier, but there is more workload, I guess.
The job is never easier.
Yeah, true.
The job is never easier, and the understanding of the monument is a must. I think I included that in my presentation, that you have to understand the monument, even if you are using hand measurements or the latest equipment or whatever. And I consider myself very lucky, because during my career so far, I have used from the most primitive instrumentation and methods to the most advanced that we are blessed to have now. So I remember when back in the 80s, I was documenting the Knossos in Crete. I was using an instrument that was measuring only angles and not distances, because there were no electronic distance measurements then. And we had to measure the distance from the instrument to the point with a steel tape. So you understand, this was a torture, because you had to go once to put the marker on the wall. And then you had to visit the point a second time to measure on phase 1 of the instrument. And because you wanted accuracy, you had phase 2. So it was a third time that you should go and climb up on the wall to put the tape twice on the wall. So our life is easier now, provided we have powerful computers. And what we can do now is to produce more data, more results that we can exploit and produce results like the ones that you're going to see, or of course, Kyriakos, you have seen them. I'm addressing the rest of the audience.
Yeah.
But I think that one of the great advantages is that when you have all these points and when you have all this data and you have forgotten to produce a drawing or a section or whatever, you can go back to the data and produce that section. In the older days, you have to go back to the monument. So we had to travel back to Jerusalem or to wherever the monument was situated to retake measurements for that forgotten or needed drawing. So I think this is one of the major advantages that we have now.
And if I would like to add to your comment is about the educational aspects of the whole effort in this seminar, is that since these are 3D models and since the youth is acquainted to IT technology, information technology, they can easier understand a 3D model rotating rather than reading an architectural plan. Even the general public, they can see the Edicula rotating and understand how it looks. But if they look at top view, a side view, a facade, they will not be able to understand how big it is, how it looks like. And it's not easy for a non-engineer to realize what he or she is looking at.
Definitely, you are perfectly right. Yes, of course.
Although I'm just consumed all the break, I guess. Or not?
No. Do we have any other comments or?
Kyriakos, if I allow me, there is a similarity between the two seasons, the two periods of documentation. The people
Yes.
who is the similarity because the people circulating inside the temple, inside the church is done more.
It's a major obstacle, yes.
And independent geodetic and photogrammetric methods and instrumentation in this period, the situation, it is difficult inside and outside of the Holy Edicula. For this reason, more measurements was carried out at the night.
And the people may not realize, if I may continue, that there were restrictions from the churches. They did not allow all spaces to be accessible. I recently saw a plan of the church, and they had they did not record the interior of one of the rooms around the rotunda because they said they would not have access to this room. These are peculiarities of this whole project that, as a group, we managed to have access to most of it, but as you may remember, we did not have access to some of the parts of the church. For example, when you were documenting the underground systems, remember all the difficulties?
Well, this is a peculiarity in religious places that we have encountered in many other places that we visited together with George and other colleagues. That that the religious persons like priests or whatever holy persons are very reluctant to share information. And sometimes it's funny that I remember once we were measuring an area back in the 90s, and we ended up at a wall. And then from the other side, we also measured, and we ended up on another wall. The in-between space was about 6 meters. And when we asked the priests, what is behind that wall or behind the other wall, they said, it's nothing, it's wall. You can't have a 6-meter wall on the top floor, okay, of a structure like that. So when we insisted, and they said, okay, we cannot hide from you. There is a crypt with some precious jewels or crosses with diamonds, etc., and some you know, how should I say? Okay, clothing, you know, official clothing with golden threads, etc. So please open it. We just want to measure. So it's and this is an advantage of having all the points in the same system. We understood that there was a 6 meter gap between our measurements from one side to the other. Okay. Okay.
If you allow me about photography now,
Yeah.
we have difficulties. We had more difficulties then than now, because if you remember, Professor Georgopoulos, that in 1999 we were in Israel. We had to send all the films for developing back to Athens. So we didn't know what we had.
Yes.
We had to wait 2-3 days for the films to come back, so we could continue our job there.
Yeah,
So
you are talking about the color films because we did the processing and the developing of all black and white films and glass plates, whatever we, okay, not glass plates,
yes,
cut film plates that we used. I remember the photographer we had
we
then.
had a dark room.
Yes, we had set up a darkroom there, which is not necessary anymore. You can
Yeah.
see straight away on the screen of your camera. You can see the result, and this is also an advantage of this instrumentation. And you don't think about the cost of the film because film based on silver was very costly, was very expensive. So nowadays it doesn't cost anything to take 1,000 images and then throw away 800 of them. Just delete them. But you
True.
couldn't do it back in the 90s. Okay. Okay. Any other comments? Do we have any other comments? Okay. If that's not the case, then we can stop here and start at 5 o'clock Athens or 4 o'clock Italian time or wherever you are. You can
Yeah,
calculate. Okay.
that sounds fine. Yeah, okay.
So it's 8 minutes break,
Okay,
and we start with George again.
perfect.
Okay. Dear colleagues, I think it's already 5 o'clock, so we can start the third part. George, you are on. Please. You stop sharing now, eh?
Just a minute. Just
Okay.
a minute, please. Okay. Now my presentation is there.
Yes, it's
Okay,
okay.
my presentation is okay, I think.
Yes, yes, George, you can start.
And in this part, we can see something about the monitoring of deformation in the Holy Edicule during the works of the protection of this monument. First of all, it is well known now, today, that structural health monitoring involves all the observation and analysis of a system over time using periodically response measurements to monitor changes to the geometric properties, to the geometric characteristics of engineered structures, such as monuments, bridges, dams, and buildings, of course. For long-term structural health monitoring, the output of this process is periodically update information regarding the ability of structure to perform its function in light of the inevitable aging after extreme events such as earthquakes or blast landing. Structural health monitoring used for rapid condition screening and aims to provide reliable information in real time regarding the integrity of the structure. There are different methods, and of course there are different sensors, different types of sensors all over the world in order to apply this structural health monitoring. Measurements may be taken to either directly detect any degradation or damage. There are different methods, as they know as static monitoring and monitoring in the real time. To direct monitor the state of a system, it is necessary to identify features in the acquired data that allows one of the most common feature extraction methods is based on correlating measured systems. After this small introduction about the structural health monitoring, because it is appropriate in order to understand the next slide of my presentation, as we can see the permanent 3D geodetic network, which was established in the church of Jerusalem in order to monitor the deformations during the works of rehabilitation. This geodetic network was realized in July 2016. This network consists of 3 points which was placed at the upper stage of the rotunda. These control points were created using a specially manufactured control metal plates, such as, yes, this is the one of the 3 points. Using this construction, it is appropriate in order to minimize or remove the centering and leveling errors when a total station was placed in this point. 10 points are placed on the roof of the Holy Edicule at height of about 12 meters from the ground using high precision mini prisms. This is the finger of the network in the plane, of course, ground plan. This is the 3 points of the rotunda, and all others 10 points, of course, on the roof of the Holy Edicule. One of these points is the fixed point, point 1, and the other points was used in order to determine the displacements or the deformation. Is the same rule. There is another. This is another photograph or figure about the positions of the points of the 3D geodetic network. This network was measured horizontal. Measure horizontal angles, vertical angles, and distances in different time periods, phases as known, by using high precision total station. In this case was used the total station Trimble S9. This is during the rehabilitation. The first phase was carried out on July, and the final phase is January 2017. As I remember, about 2 persons was indispensable for the measurement realization, which last 3 plus 5 hours each time. That depends on the accessibility difficulties. The 3D network was adjustment network was carried out by using least square method, and the RMSC of X and Y coordinates fluctuates from 0.1 millimeter to 0.3 millimeters, and the third coordinates, orthometric height, fluctuates from 0.1 millimeter to 0.2 millimeters. That means that this network had a high sensitivity network, which is able to detect displacement of 1 millimeter for confidence levels 19.5%. About some results of these different periods, and in this diagram we can see the vectors of the displacements for each one of 10 points at the Edicule, at the Holy Edicule. During this period, works rehabilitation is very important. In these diagrams, we can see the change of the coin position along X-axis this displacement fluctuates mainly from about 10 millimeter, and the same displacement is 6 millimeter in along y-axis, and along in height axis. Okay, this is the first method in order to determine the displacements. The second method is to use a permanent monitoring system. What is this? This is a system who include a total station, that is a specific total station which it observe in a specific time, in a specific period, a prism, in order to monitor the future behavior of the whole Ediculous body. The same 10 points was used. The permanent monitoring system consists of the total station Trimble S9, which is placed at the point 2 of the network. From this position, just a minute, please. This is the point which the total station was placed, and from this position there is a clear view to another 10 points of the network, from which at the roof of the Holy Edicula. The total station is connected with a laptop, and why connected with the laptop? The laptop, there is a software which is used for the real-time monitoring. The software allows the communication with the total station, the organization of the monitoring scenario, the registration of the total station's measurement to all the select points, the check of the measurements at the data management, the presentation of the results of the check points displacement in real time, either in a table form or in a diagram form, and of course the decision making. This is the real photograph about the permanent monitoring system. This is the laptop, and of course there is a possibility to communicate with total station. As the worksite has internet access, the laptop is by a cable or Wi-Fi connected to the internet. This connection allows the data and the results, of course, transfer to any other PC worldwide. Thus, any authorized user, of course, can be informed and evaluate the results from any place. There is different ways to be done. In this work, we designed to be activated by the use of the TeamViewer software, and the The aim of this connection is the real-time information of the working team for any displacement which may be occurred on the body of the holy edicule during the rehabilitation works. There are some diagrams during the monitoring and of course the displacement in three direction, northing, easting, and height. And in this diagram we can see there is a possibility to extract results daily, such as in this diagram, different diagrams, daily, weekly, and monthly. This is the diagram for the same. There is a peak in a vertical position because this area, the workers replaced the part of this the part of the article in this area. The system operation was started in August 2016, performing a virtual and a real-time measurement series. The virtual measurements were carried out in order to organize the observation and check the multi-connection and the communication between the involved systems. The user could the duration, of course, of this successful virtual campaign was 4 hours. I remember 4 hours, and the real monitoring was carried out on August 2016 during the progress of the rehabilitation works. These systems worked about 6 months daily during the rehabilitation work. The monitoring was carried out about 7 o'clock at night to 5 o'clock morning. These diagrams, in these diagrams, we can see some information about the displacement, about the deformation of the same target, of the same target of the same point. Okay, I have a small video about the operation of this system. Just a minute to just a minute. It is okay. So, to share this. Okay, it's to see the system, the total station in this area. It is easily for us to see that the measurement carried out at night, because there is only lights, and we can see the system who work without observer. And of course, this is very important for us in order to check all the position of all the targets at the roof of the holy article, and communicate with the workers in order to be careful in the area where the displacement were more. This is my presentation about the monitoring system during the works rehabilitation, and of course I am in touch in order to speak about this system.
Thank you very much, Professor Pantazis. Having also experienced this system live in Jerusalem, I think it's very impressive. It is really impressive how it could work and how it could send us the results. And it's a pity that this was taken down right after we finished the job. We could have it still operating, I think. Anyway, let's keep the questions for the end, and we proceed to the final presentation of Sevi. Mrs. Tapeinaki, if you like to share your screen and start your presentations, and then I would invite all of you to prepare for some discussion. I mean, there's definitely there are questions, and please try to participate to the discussion session. Thanks. Sevi.
Okay, good afternoon again. Just tell me that if you can see my presentation. It's okay.
Yes, okay, we can see it.
Thank you. Now we are going to discuss about the data processing of the data acquired that I mentioned in my previous presentation. Some auxiliary areas of the Church of Resurrection were converted into offices that we used for team coordination, work planning, equipment storage, and of course the rough data processing that was necessary, mainly for checking the data that we acquired and detecting any omission, and of course to make the additional measurements where necessary. And the final and proper data processing was done after returning to Greece. An image-based modeling software was used for the orientation of the images, their georeferencing, and the production of the dense point clouds with multi-view stereo reconstruction algorithms. Additionally, a 3D data processing software was used for the registration of the point clouds and their georeferencing, and for editing the point clouds. The final integrated point cloud was produced by cleaning and merging the two point clouds, the scanned and the NVS point cloud. Subsequently, the accurate 3D models and the detailed 3D models, textured 3D models that were generated were used for the production of all other deliverables. The Agisoft Photoscan was the image-based modeling software that we used for image orientation and georeferencing. Here there are some use of the oriented images, and for the production of the NVS point clouds. Okay, and here is a view of oriented images acquired for the geometric documentation of the Corbus excavation is a space underground near the Holy Edicula, south of the Holy Edicula. And the space was very narrow and total dark, and that's why we used an action camera there and this light projector that we can see in this image. The softwares that we used for point cloud processing was the Photogrammetry for the cloud registration and Geomagic Studio software for the point cloud processing and the surface modeling. During processing of data, we had to deal with some issues like the scanner noise. As we can see here is the north facade, and if we make a vertical section on it, we can see that there are some areas where the points are wrong, and we had to delete them. It was difficult at the time because the Photogrammetry software didn't have the appropriate filters. Now they have it, the new versions, but then the version that we used didn't have these filters. Fortunately, we found some filters in another way, and we managed to eliminate these points and to have the clear surfaces. Another issue came up during process of the interior scans. We noticed that the points on the marbles were on curved and not on flat surfaces. It is more likely to be the fault of the material absorbency, since the curves follow the patterns of the marble. And here is another view that we can see clearly the problem. And the solution was the dense point cloud from the image-based modeling softwares. And we can see here that in this point cloud, the surfaces are correct. Very important was the processing of the GPR data that were used for the documentation of the construction phases. And we converted the measurements to polylines that were used for the 3D reconstruction of the Holy Rock and the placement in the 3D model. Now, the results of all this work of the geometric documentation during all phases of the project was in various cases and level of detail, high resolution 3D texture models, orthophotos of exterior facades and details, interior, etc., horizontal and vertical section with orthophotos or not, orthophotos of the 13 panels at specific faces, a video of the 3D models and the stereoscopic video, and 3D printing. All these results met and fulfilled the requirements of the entire interdisciplinary project team during all phases. Now we can see some examples. Here are the horizontal sections with projections in various levels. It's from October 2016. Okay, and on top. These are horizontal and vertical sections from the 7 project phases per 10 centimeters. These sections were used for fine element method they used these sections to create the model that they needed. And of course, they are very useful because anyone can make measurement thickness measurements on them. This is the horizontal section of the Corbus excavation and a vertical section looking east and west. The orthophotos of them. Orthophotos of the facades. Here we can see the facade, the east facade on May 2015 and March 2017, initial and final phases, and one cross section of the tomb with an orthophoto. Orthophotos of the interior. We can see the whole interior there. And orthophotos of details. This is a detail in the Angel's Chapel on top of the entrance to the Holy Tomb chamber. And here, this detail is the representation of the resurrection on top of the Holy Tomb. Orthophotos of details we can see here the major difference between the initial and the final state. And here we see the four facades of the Angel's Stone in the Angel's Chapel, and the frame that placed in the tomb chamber, and the pilgrims now can see the holy rock from it. High-resolution 3D texture models were produced also, as I mentioned. This is the texture model of the tomb. Also, the opened tomb in October 26, 2016, and the orthophoto of it. Just to make some remarks here, high accuracy, fully controlled geometrical documentation is achieved with the application of a combination of documentation techniques. Scans, image captures, high accuracy geodetic measurements can ensure accuracy and control. Always, it is necessary the interdisciplinary approach. Kyriakos mentioned that before. And we can say that we have a 4D documentation of the monument during the rehabilitation project. Geometric documentation gives the 3D data. In different phases of the project, we have the time is the fourth dimension. Just to see an example of it, this is the state of main, the initial state. And if we focus here on these two panels, we can see the changes through time on October 2016, on January 2017, and the final state on March 2017. We can see the changes through time from initial to final phase. And another view. And this is the 3D printing that was produced for the needs of the exhibition that took place here in Athens. And this is the video of the 3D models. We have to mention here that this is not a video that we took with a camera. This is this video was produced in a digital way in the 3ds Max software. From using the two models, 3D models of May 2015 and March 2017. This is the interior. If someone visits the place now, could never see these details in there, because as we mentioned before, the interior is very dark and only some candles give the light. And these details are not present to the pilgrims. Okay, and the video ends with a top view of the tomb. Okay, thank you very much for your attention. I think I did a short presentation again in time. I was anxious because I thought that I had to say a lot of things, and I merged some of my slides. And that's why this is the result. Sorry. I hope it was interesting for you, and any questions are, you can say, you can ask if you want.
Don't worry. I think you did very well, Sevi. Thank you very much. I have to add that whenever I see this video, I'm always admiring the result of the work. And I see Kyriakos and Katerina Delegu that are also present, and they should remember how dark those frescoes were on the top of the tomb chamber. And now we can admire them. I don't know now, but with the video we can admire them at their full, let's say, colors, etc. So I expect that tomorrow you will hear more about the details of the how should I say, the conservation that took place also on the frescoes and on the marbles, and which maybe they are, I'm sure they are more interesting details than just a geometric documentation and the monitoring that we presented. So I think that tomorrow will be an even more interesting day. Okay, now I think we are now at your disposal. If you have any comments, any experiences that you would like to share, any questions, I think this is the how should I say? This is why we stage this seminar for you to answer questions, for you to ask questions, and for us to answer. So we are at your disposal. I see two hands. One hand was raised right from the beginning, but Adisela Wiener.
Yes, thank you very much, Professor. I'm from Bezalel Academy. We are partner with you on the project. And I would like to ask about a continuous monitoring that you were, I think, already start to answer the question, but there is also very high significance to a continuous monitoring, even after finishing rehabilitation work and conservation work, because the place is under, like, it's working, it's under visitation all the time. And why it wasn't continue, and is there any purpose of trying to keep on monitoring this monument at the present time?
Before I give the word to George, because he's the most competent person to answer that, I had a discussion with Regina, and she will show a video. She will share a video from the works there. So this is like a background video that we can all see. So George, please.
Yes, this question is very important, and important for us, of course. This monitoring system was organized in order to continuous observation after the end of the rehabilitation and in these days. Unfortunately, the conditions in the Holy Sepulchre, and not only with the COVID, no, independent this situation. The operation of the system had stopped suddenly at the end, after at the end of the program, and unfortunately there isn't the possibility to observe the situation of this monument at the next years.
He was very diplomatic, I think. I don't think that any one of us, even Professor Moropoulou, will be able to give a definite answer to that question, because we were all expecting that the works would continue. The situation that we discovered underneath on the Corbus excavation and all the systems was rather alarming for the structural health of the Edicula. But you know, sometimes in such places, the decisions are not taken by or with, let's say, earth and logic. but also some divine minds take different decisions. So I was a bit less, but also diplomatic.
I completely understand. Thank you very much.
Thank you, thank you. Any other comments, questions?
May I add to your comment about the reasoning why monitoring is important, Professor?
Of course, Kyriako, of course.
And just to reply to Adi's question, why would be important to continue monitoring the Edicule? As Professor Georgopoulos mentioned, the foundations of the Edicule are not stable. Professor Georgopoulos, you may remember Professor Marino's work about the foundations of the Edicule. The whole Edicule is actually subsiding, but it's not subsiding uniformly. So if we had the monitoring system, we could monitor how it's deforming. Actually, the foundations are differentially subsiding. That's why it would be important to have all this data and perhaps be alarmed that it may be shifting to one way, to one direction, so other. Just to continue to your comment. Sorry for.
No, it's very useful. It's very useful. Okay, but of course these deformations are not that great, because if they were, then we would have some unfortunate incidents by now. So it is deforming, but in a very slow manner, I think.
I also add something in this part of the discussion.
Of course.
This project had the 3 pillars. So the third pillar was the sustainability of the monument, and monitoring it is part of it. So it's important for us to set the methodology. What happens next is part of timing of other consequences, but the methodology needs to be set that monitoring is part of this integrated interdisciplinary project for rehabilitation of such an important monument. And if you remember yesterday, Professor Kores also expressed how this, how the Holy Edicule is not just part of the Holy Sepulchre Church, but also in the open city of Jerusalem. So we have to see every monument in all of its dimensions, not only as the monument itself, but as part of the city and the society and the history of it, and especially the part of the history that we are now. I mean, sometimes it's time to extend the methodology and the project in certain times, and then in other times it is not. So we just want to set. What I want to explain is that we want to set the methodology, and that is why we are preparing this seminar to explain the methodology and to teach the students some skills and and how to open their minds in order to create other methodologies as well.
Yes, you're perfectly right, Antonia. Thank you very much for the comment. Yes. Do we have any other comments, questions, thoughts, ideas that come to your mind? Or similar projects, or projects that you have participated and you want to share your experience? It would be nice now to listen to experiences from other countries. It's a good opportunity, I think. And you shouldn't be shy, unless you're all sleeping. Apart from those that you have your videos on.
Can I be the bad guy and ask another question,
Yes,
Professor?
of course. You are not
No, it's not actually a question. It's I just realized something that Sevi said, and all these years I've never realized that that small detail. She said that the last video she showed with the Edicula from the interior, that they could record it with an ordinary camera. But and then I realized that yes, but what's the beauty of this 3D model? The beauty of this model is it is a three-dimensional model. You have every the location of every point. You can do sections. You can do things like that. With a video camera, obviously you can fly inside the monument, but you will not have anything more than just a video of this. And it took me 5 years to realize that. I mean, I always see the products of this model, but I never realized that, yes, of course, the very impressive video could be done alternatively, but there is no actual use for it.
I think, of course, I will give the word to Sevi, but I think that it could not be done in another way.
Indeed, true.
It is impossible. And whenever we show this video, we always stress that this is not a normal video that we took a camera and we went around the object, the real object, but it is a video produced from the 3D model, because this is the only way that you can admire the result of our work, our common work, in such a beauty. There's no light, there are lamps now hanging, and perhaps also the frescoes are dark from the smoke, etc. And it's impossible to see the Holy Edicula as we saw it in that video. And of course, it's very deceiving when somebody sees that video. Might think, okay, they took a camera and they went around before the lamps were put on, etc., without pilgrims, but it's not the case. So it's a result from the artificial 3D model. Of course, we have the 3D model to measure and to make sections and to do other things, but also the virtual tours, because this is also another way of exploiting 3D models, is to perform 3D visits, virtual visits. And even during this time of pandemic that we experienced the last 2 years, and we don't know when it's going to finish, I think that virtual visits and everything that can be done from a distance would be always welcome by visitors, by prospect visitors that cannot travel or have restrictions for traveling, etc., etc. So, Sevi, if you like to add something on Kyriakos' comment, and then I will give the word to, is it Adisela? Okay.
I cannot add something because you covered the whole issue here. Just to mention that I am and we are very proud of this video, and maybe it sounds a little strange, this thing that I say, that we are proud for a video, but it's not just a video, it shows our work. And it was a very difficult work and very important work. And these 3D models and the data that we have, I didn't mention that, but we have a lot of data that we didn't have the time to process. And we have the data, or we didn't have the time to process it and have the same results of like the initial and the final phase state. We could have a video of all the rehabilitation project, the 7 phases that we documented. And of course, we can do measurements and cross-section or whatever with this data, but a video, a tour, like Andrea said, is very important for people that cannot manage measurements and sections, etc. And they can take the information that they want from a tour like this. Just, thank you.
Thank you, Sevi. You wanted to add something? Adisela?
Of course, Andrea, this is, as Mrs. Labropoulou mentioned, this is an example how different scientists collaborate in order to save, to protect monuments such as Holy Edicula. This is the basic result of this collaboration, and for all the participants in this seminar, this is the basic role of one scientist or one member of our team.
Okay, thank you. Thank you. So you wanted to make a comment?
I wanted to ask another question, please.
Yes,
because many of you were there on site in the 90s, in 2016. And you just mentioned now, Sevi, the issue that recording and documenting is a tool for many different aspects. And I wanted to ask you whether during your work there, results of the recording that you start to gather while working in the site was used as a tool for decision making in situ. That if you had a question, you start to gather data, and then another person from another discipline that was with you inside was using the documentation and recording results in real time for having a decision on rehabilitation, on conservation, in stabilization, whatever aspect that was questionable.
Yes, that actually was happening through these 9 months that we were there, from the initial state to the final. An example that I can remember now is the scanning of the interior of the Onion Dome that I showed you in my presentation. We did the scanning. It was very, when we, okay, let me put my thoughts together. First of all, we had to find the way that we could do the scanning in there. And the scanning was not the first solution for the documentation of the Onion Dome. We discussed a lot of methods that we could do. And then, fortunately, people there from that worked with us from other, I don't remember what specialist is the man that gave us the idea for this construction. If you remember, Andreas, you can add it later. But when we did the scans, I took the data in the office and started to see if it is okay, if we could have another scanner position, etc. And Mr. Mouzakis came into the office and he asked to take measurements immediately. And then there, we took the data, we did the measurements, he took the information that he needed, and they immediately started to work how they will conserve or the work that they had to do in this Onion Dome. And
actually,
it was very intense, the moment there.
It was an idea of Professor Kores, if I'm not mistaken, to insert a metal base like a tripod or a quadrupod within the onion dome in order to stabilize its construction, the construction. And since the interior construction was not that symmetric, not at all symmetric, they couldn't just take simple measurements and design the metal base. So this is why we scanned. We gave them the real situation, how it is, all these pieces of wood nailed together. And from these measurements that Sebi mentioned, they were able to design the metal base that when it was constructed, it fit perfectly in the onion dome. So this is a fine example. And of course, there is another example that came to my mind. When we first started with the situation as it was before the work started in May 2016. And we had, we were the first to go there before that in May 15 and January 16 to do a documentation of the object as it was before any work. And based on these orthophotos that we produced, the panels, each piece of the panel were given a code. And when it was taken out, there were those drawings with the codes there so that they knew how to reassemble the panels, which each panel had, let's say, 10, 15 pieces that they took off and they rehabilitated and scanned, and they brought them together 6 months or 5 months or 7 months later. And so actually from those drawings, on those drawings, they were able to mark numbers or codes for every panel. So this is another, let's say, immediate use of the results. Okay.
Can I add some applications of this? One application was what Professor Pantazis did. Before we cut the iron frame, the engineers had to verify that all the deformations have been zeroed, let's say, like have been diminished. If they haven't been diminished, then the civil engineers would not allow the removal of the frame.
Yes, yes.
The other application was at the beginning of the project when chemical engineers and survey engineers, we recreated the 3D model of the rock. We verified that there was a rock inside, remnants of the original. I will show you tomorrow. Remnants of the original Edicula, and we used that to calculate beforehand all the necessary interventions that had to be done. How much mortar would be added, the layers, and having all the civil engineers then had all the information about the internal structure of the Edicula. Without this, they could not move forward to do all the interventions. So that was a combination of geometrical documentation, prospection with NDTs, and understanding of the structure. So yes, indeed, this is correct what you said.
And also this brings to my mind that in the phase of the grouting, the civil engineers were asking, could you tell me what is the opposite side of, if I bore a hole here, where am I coming into the inside, or vice versa? So they wanted to make sure that boring a hole for the grouting from the outside, it would not damage something in the inside. So this was not very easy to do it just by a hand measurement. So in the 3D model, it was easier, and we could verify that. So you see, there are a lot of implementations, provided that the disciplines talk to each other, they understand what the needs are of the other, and they have the, let's say, the knowledge to produce the correct result, because this is also very crucial. We could do other things that were not useful for anybody, so we should always have an open ear, an open mind to what the needs of the others are when we collaborate in such a project. And this goes vice versa, of course, yeah. Antonia, unmute yourself because we can't hear you.
Adi said the question very correctly. The question was, how is this useful in decision making? So that was the very important question. And as Professor Georgopoulos usually already said that yesterday, because we had a very tight schedule, the monument had to be rehabilitated, fully rehabilitated in just 1 year before Easter 2017. So we only had 1 year to do that, to set the working site, to make the measures, make the rehabilitation as well, and have it ready for Easter 2017. So the main two solutions that we found was, the first one was to set in on-site laboratories. We had 2 on-site laboratories. One was the conservation laboratory, and the other one was the documentation laboratory. So we had in real time 24/7 information on the monument, in addition to all the trips of the interdisciplinary team from Athens to Jerusalem monthly, and everybody. I mean, we had a lot of people from Athens every day on the site, if not all of them. And the second important solution to have the monument rehabilitated in 1 year was to adjust your decisions through decision making and discussion with the guardians of the tomb. So the team got the information, discussed about adjusting the proposal, because we had the study from 2015 to 2016. The study took a year to be prepared, but it was always adjusted, and decision making was different each time because we had this information. So it is important to use the information while the monument is being rehabilitated to adjust the decisions that are made. This is the only way, not only to have a fast rehabilitation, but also to have the best possible rehabilitation. Otherwise, you develop the project as you had it planned, then you assess it, and then you make changes. It doesn't make any sense. You have to adjust your study with according to the measurements that you are taking during the rehabilitation, not during the study. That was the whole idea, and that is the main methodology that we're trying to prepare to show that a true rehabilitation has to be adjusted, and not only scientifically, but also according to the needs of the owners of the monument, according to their decisions as well. So the decision making wasn't only scientifically, it was also politically made.
Correct. Well said, Antonia.
Thank you. And if I can also add to the previous discussion about the importance of your 3D model, I want to express my own thoughts as well, that the rest of the team saw this model during the preparation of the exhibition at the Byzantine Museum in Athens. That was prepared about a month, about a year. When was it? It was in 2018. It was about a year after the completion of the project. So we also first saw this model while preparing the exhibition. And this exhibition was in collaboration with the National Geographic Society and their own model of the Holy Edicule. which was also quite impressive. It was in, I don't know, maybe you can express it as well. It was in a very big screen, and you kind of went inside, got outside, saw the Edicula throughout the edges. But the NTUA model, your model that was in the other hall with the rest of the information of the other teams as well, although it was in a smaller screen, let's say that as softly as I can say, it was much more impressive because it was more authentic. It was the real model. It wasn't just a representation like the National Geographic Society had made, with many mistakes and many... Regina is laughing, but it's true, isn't it? It wasn't as impressive, but it was true. So it was really authentic, and that's why we chose this model to present it on the poster of the exhibition so that everybody could see it in the city, not only those that came into the exhibition. If I can share my screen and show the poster of the exhibition. So I don't know, can you see that?
Yes.
Yes, yes.
Okay, so this was the poster of the exhibition outside the museum. In the museum is in a very central place in Athens, and a very busy street with lots of buses as well. So it was a way to show the Holy Edicule itself, not just the work of NTUA, outside the museum. It's not always easily chosen to use one of your main aspects of your exhibition in your poster. Usually you save the best part for inside the exhibition, if I can explain that. But it was really important for us to show the Holy Edicule to the whole people of Athens, and that's why we keep using this model in the posters of the international conference we have preparing, the TMMCH conference.
Next week, or in 2 weeks' time, yes.
Yes, in 2 weeks' time, because it is important to show the work, and not only the monument itself. So the work that was done, not only the monument rehabilitated, but the process of the rehabilitation. And this 3D model expresses the process as best as possible.
Thank you, Antonia. I think that the model was the work of the whole team. Okay, it's not our model or your model, or we worked as a team. Okay. Yes, okay, thank you very much. I think we are past the foreseen time of closure by almost a quarter. I thank you for your presence and attention. I see that some people are logging out. And I hope that if we repeat such a seminar, we will meet in person. Okay, and that this coronavirus situation will stop sometime. Okay, and I have to thank all my colleagues that did the presentations, and at a very short notice, I must say. And I would like to finish with a big thanks to Professor Moropoulou, who asked us and included us into this interdisciplinary team. It was once in a lifetime experience, at least for me, and I think for all the colleagues that are here. Okay, so thanks very much. I think we can close here.
Thank you very much. Thank you.
Thank you very good.
Thank you.